All right, so we're going to graph this function. So let's go over to Desmos, and I'll show you guys what to do there. And so you want to, you can type in the y equals if you want, or you can just just type the function. But I'm going to go ahead and type the y equals. So y equals, and then we want the absolute value bars, which are down there on the bottom left, right above the ABC. You can see the two vertical bars and then the A in there. So just hit the absolute value button, and then we want x. And you might notice that the right side of the bars aren't dark yet because it's kind of waiting on you to see if you want to type more. But just go ahead and hit enter, and it'll close those up. You can see the absolute value graph here. Something you may want to do is over here on this top right, there's a little wrench. So there's just some options in there. I like to turn mine on projector mode because it just makes everything a little bit bolder. So it's just something you can do. And then if you see this gear up towards the top left, so if you click on that, what that allows you to do is change more things I'm going to show you right now, but there are more things you could do. So when you can, if you tap on, like for me, it's the red circle. If you tap on that, then you can change the color of the graph that you have here. And since this is the parent function, I'm going to leave it as the black one. But you could also, make it a dashed line if you wanted, or you could make it like a discrete graph if you wanted. But, okay, so there's options there to change those things. And you just hit done. Okay, so here's our parent function. And this is the absolute value of x. This is what this is the most basic graph of this type there is. Okay? And I'm going to take a screenshot of this so I can bring it into my notes and we can draw on it a little bit. Oops, that didn't work. Mm-hmm. All right. So it's in here. So you're gonna end up needing to draw this in here, but I gotta cheat a little bit. So we need to get some points, right? Let's kind of write down some points so we can fill out that table over there. Oh, my bad. What do you mean, Kenzie? What are we supposed to be using? Like what website you're supposed to be using, or what are you writing on? These notes are attached to your Google Classroom. The very most recent assignment I put in there for you. I think it was called 1-2 Transformations of Graphs. And then we're using Desmos to do some graphing, and then we're transferring that information to our notes. So we need a couple points. Come on. Sorry. It's like the wire has to be in the exact right spot. So the most important point on this type of graph and like a quadratic, a parabola graph is right here at where the corner is, where it changes from decreasing to increasing. That's called your vertex. And we can see that the vertex is right there at 0, 0. So pretty much any parent function, the vertex would be at 0, 0. And really from there, I'm just going to kind of pick random points, some on the left, some on the right of the vertex. So nothing special about any of these, like -5, 5, or -2, 2, or 1, 1, or 4, -4, 4. Like there's nothing special about the other points I'm picking. They're just points somewhere on the graph. But again, some on the left side, some on the right side. So just kind of, sorry, I bumped the wire. So 0, 0. Oops. -5, 5, -2, 2, 1, 1, 4, 4. So remember what we're doing, right? We're plugging that x value into the absolute value function, so then it's giving us the absolute value of that number back out. So we plug -5 in, we get 5 out. Plug -2 in, we get 2 out. Plug 0 in, we get 0 out. And I plug 4 in, we get 4 out. So, and a whole bunch of other points too that we could have written down. So the vertex, that's going to be an important kind of vocab word for you guys. knowing where the vertex is, just identifying it. So again, with the absolute value function, it's right there at that corner of that V. Okay. Another important vocabulary here is what's called the axis or line of symmetry. So you guys would have talked about symmetry in geometry. The axis of symmetry is the line that divides the graph down the middle so that both sides are mirrors of each other. Not all graphs have these. This graph does. We can see that if we mirrored this side across this line, or reflected it across this line, it would just be right here. They would just, both sides are the same, right? And you guys should have talked about symmetry in biology before also. This is the axis or line of symmetry. And so because it's a line, it has an equation, right? And so if we think about all of the points on this line, they all share one thing in common. So all those points have the same x value. They all have an x value of 0. And so that's the equation of that line, x equals 0. So when you look at axes or lines of symmetry, they always are vertical lines for what we do. Okay? And then, so it's going to be some sort of x equals number. Right? X equals 4 would be, a vertical line over here. X equals -7 would be a vertical line over here. A lot of times we don't look at something like this and think of that as a line, but it is. Okay? Because it doesn't look like y equals mx plus b or something like that. So, okay. So again, vocabulary, these are things that you are going to be expected to know. Axis of symmetry, it's the line. You don't need the definition down, but you need to know like what I'm talking about. So like axis of symmetry is the line that divides the graph in half. Okay, and then the vertex is going to be that point on the basically where it changes from decreasing to increasing. Okay, so the corner. So if I was going to look at something like a parabola, if I just sketch one out real quick. So maybe it looks like this. Okay, so its vertex would be right here, right? And its axis of symmetry, like that. So maybe this is a 4, right? So maybe that vertex is at 4, -3, right? And then the axis of symmetry would be at the line x equals 4. So notice how these two numbers are the same, right? The 4 and the 4. That's always going to be like that. The vertex will always be on the axis of symmetry. So those numbers will always be the same, right? Here we had 0 and 0, right, for the x value. Okay. So axis of symmetry, that line down the middle of the graph, vertex, it's either the highest or lowest point. If the graph was upside down, then the vertex would be the maximum value, not the minimum value. Okay. So that's our parent function. That's what just plain old absolute value looks like. Okay. We're going to take that. We're going to start messing with it. Okay. Kind of like you were on Friday, where you're dragging stuff around or typing numbers in. Typing numbers into stuff. Okay. So let's go back to Desmos.
Can you go back for a second?
Sure. Yeah. All right, Kenzie, are you typing stuff on?
Does that say AX is of symmetry?
No, it says axis.
Like, what is, oh, okay.
Like, Kenzie, are you writing the notes down like on like, did you print the papers out and you're writing it down, or are you trying to type it on it with the Doc Hub? What wasn't working? Is anybody else having trouble in Doc Hub? Haven't heard anything about that today. Might just need to like refresh it and try again, because it's usually Okay. Yeah, I mean, it's working for me, Kenzie. I'm going to go to DocHub. I think what we might try. Yeah, I've definitely tried to refresh it and see if that works. But, you're doing this, using the text boxes, 0. Oops. Oh, that's kind of frustrating. It's got to be a better way, right? Of course, I don't do this much, so don't really know what to do. And like -5. Nope, over here. 5. Just typing stuff in somewhat imperfectly. So -2, 2. And then on the graph, I would probably have a line tool up here. Where is it? No, there's a line tool. Here it is. So on the pen, you got a tool. So you can. So going from corner to corner. So from the top left to the vertex, or the origin, and then you can do it again from the other side. Well, I'd probably do something like that. If you need to then come in here and say, okay, there's my vertex. It's 0, 0. Something like that. If you can't see that, you can drag that. That's probably what I'd be doing, Kenzie, if I were you. If you're trying to type it out in DuckHub. Come on. Being weird. There we go. It's not perfect by any means. Did that help, Kenzie? Or? Okay, so let's go back to Desmos. So what I do is don't erase the first one you did. Let's type in a new one. So I'm going to say y equals an absolute value again. And it said x plus 3. So x plus 3. And then go ahead and hit enter. And again, if you feel like you want to change the, if the lines are the same color, it can be kind of distracting. So if you need to, you hit the gear and then you can change. I like to see the red versus the black. Seems to pop a little bit more. So what happened to the graph? All right. How did it change? What we want to talk about. So Addison, how would you describe the change here from our parent function, which is the black one, to the red one, which is our new one?
Mine looks the exact same. It didn't change.
Did you type x plus 3?
Yeah.
It should definitely be different.
It's not.
Didn't slide over at all?
I zoomed out on everything. It's the exact same.
Did you hit enter?
Yeah.
Do you have both of them, like the top one and the bottom one graphed?
Yeah.
Okay. What about just looking at my screen? How would you describe it?
It moved 3 places.
Okay, move 3 places.
To the left.
The left, right? Okay. I'm not sure what's going on with your screen though. So there's a couple things you guys need to, like, as you're writing this, the description. Okay, it says give brief description. There are a couple little kind of oh shoot, that word's evading my brain right now. It'll come back. There's a couple things you need to make sure you include in there. But so usually we say something like the graph or the function. Is we would say moved or shifted. Shifted is really the better of the two words as far as like the vocabulary. But moved or shifted. And then, like Asen said, 3 units. And then to the left. Or just left. Okay. So as far as like the things that you need to make sure they're in your statement. So what's your verb? Okay. The distance and then the direction. So those 3 things need to be in the statement. So otherwise than that, you have like some freedom in how you arrange things within your sentence there. And I'll kind of keep showing you different ways of writing it, but oh, come on. Okay, Tion, I'll see you. Struggle. Okay. Let's look at the next one. So Kyla, what do you think? When I type -3 in here, what's going to happen to the graph?
It'll move the other way, so it would move right.
Right through. Okay. Yeah, so putting a -3 in there shifts the graph right. Okay. Thank you, Kyle. So then you could say, again, just kind of, it's a little bit of play you have here. So the graph, or again, or you could say the function. So I don't really care like what tense you use. So there I kind of use like a present tense. So you could say like, you could also say use like a future tense. So I could say will shift left 3 units or right 3 units, I guess. And there you notice I kind of changed the order of the sentence a little bit. But again, I'm hitting those 3 kind of big things, like what's the verb, what's the direction, and what's the distance. Those things need to be a part of your statement, your description. Okay. Hopefully you noticed, and you would have seen that on Friday as well, that there's something weird going on here, right? That we say plus, and we would normally think that'd be a right movement. We say minus, we normally think that'd be a left movement. So there's something strange going on here. Well, it turns out there's this like kind of a sign switch you need to do in your head. Okay, it says +3, but it's acting like a -3, and it says -3, but it's acting like a +3. Again, we haven't gotten to the why of that yet. We will. Okay, but just starting to notice again that something is up, so you might want to just highlight that for yourself. There's a sign switch or something. Okay. This has nothing to do with this absolute value function. It happens for all the functions that we look at. So just something to watch out for, that it says +3, but it acts like a -3. It says -3, but it acts like a +3. Okay. Jake, what if we change it to the +3 outside of the function? What's that going to do? What do you think?
Give me a second. I'm trying to find. Oh shoot. The program that you're running the graphs on, that's called Desmos, right?
Yep. Just what do you think it's going to do, Jake?
I
Put +3 at the end.
That's for number 3. I think it's going to go up 3.
Okay. Yeah, right. So the graph went up 3. Right. So we'd say the graph shifted up 3 units. Okay, so as the description there, the graph shifted up 3 units. I'll write that down here in a second. Caitlin, where's my vertex right now? Caitlin? Nope. How do you recognize the vertex, Caitlin? Where should we be looking to see the vertex? What part of the graph is it at? Jarrett, where's the vertex of our parent function?
One, two, three.
Where's the zero? Where's the parent of the
3,
Jarrett?
0.
Where's the vertex of the parent function, Jarrett? Which one's the parent function? Okay, so where's its vertex?
Would it be 0, 0?
Okay. So see that point, Caitlin? That's the vertex of the parent function. Where would the vertex of the new function be, Caitlin? I don't know, my camera goes off sometimes. Let me share. No, that's not it, Jarrett. Samantha, where's the parent? Where's the vertex of our new function?
Will you say that again?
Where's the vertex of our new function, our red one?
Is it 3, 0? Are you talking about the one in red?
Yep. So there's 3, 0.
Or 0, 3, sorry.
Yeah. So 0, 3. Okay. So what happened to the vertex?
It moved up 3.
Yeah, it moved up 3, right? All the points moved up 3. That's usually the easiest point to kind of key in on is the vertex. Just because it is that corner, it's easy for us to see. So, but all of the points on the graph are moving up 3. Just, again, we can key in on that one most easily. So the graph shifted up 3 units. Okay. Mason Hayer, what about number 4? We switch that to a -3. What's going to happen?
1 second. For number 4, if we switch that to what'd you say?
Yep.
Yeah. So, x is up, and then that's saying -3. But you were wondering if you wanted to change it to like a -3.
Nope. I just wondering what's going to happen when we move on to number 4.
Oh, okay. It'll shift down 3 units if we change that to negative.
All right. And of course, we can confirm that with the program. Let's change that to. Oops. Okay, so we see that shift down. Okay. Okay, so that's the shifting, right? It's usually pretty straightforward, except for what we see with the left and right stuff, right? We're kind of messes with you a little bit as far as the direction, but seems like people usually get the up and down part pretty easily. So Kenzie, you were talking about the placement of the numbers. So when the number's on the inside, it kind of lies to us, right, about its sign, and that's the left and right movements. The numbers on the outside, on that back end of it, that's those up and down movements. That's when we see it kind of doing what it's supposed to do. Okay. So you mentioned having questions about placement of numbers. So there's part of it right off the bat. Another thing, switching along that lines, placement of numbers. Now we have a number in front of the function instead of instead of inside of it or after. Notice also that the operation is changing here, right? We're no longer adding or subtracting these 3's. We're now multiplying by 3. Okay, so it's going to have a different effect on the graph than the shift. Okay, so let's go ahead and look at the graph. Oops, that's the wrong button. Let me get rid of this stuff. So bringing that 3 into the front, right? So, Adriana, how would you describe this red graph in comparison to the black graph? Just real like surface level, like how would you describe the way they look compared to each other?
It's more narrow.
Yeah. So yeah, it looks narrower, right? It looks skinnier, it looks narrower. And what that has to do with is, is that being multiplied by 3? And so I'm going to take a snapshot of this real quick for you guys, and so I can draw on it and describe some steps. I just turned it off. That's a good job. So you guys don't need to do this part. I just want you to pay attention. So if we think about, a point on that original graph, okay, so if I say something like this point right here, okay, so that 1, 1. So when I plugged in, so if f of x equals the absolute value of x, okay, so when I plugged in 1 as my x value, right, so I can make that a 1, and then make that a 1, that means that the absolute value of 1 being 1, okay, so when I plugged in 1, I got 1 back out, okay. So if I plug in that same x value for this function, which was f of x equals 3 times the absolute value of x, so if I plug 1 into that, well, it's going to take the absolute value of 1, which is 1, and it's going to multiply it by 3, so that gives me an answer of 3. So it's spitting back out this point 1, 3. Okay? So if we compare those 2 points, right, this new point is 3 times higher in comparison to the x-axis than the original point. Okay, so the graph is being what we call stretched vertically, because now that point is higher than what it should have been. If we think of the parent as the should have been, okay, it's 3 times higher, so it's being stretched vertically. Okay, and so how do we kind of reconcile that idea of like a vertical stretch, making the graph look skinnier or narrower? Okay, so you guys all played with Silly Putty? Or a rubber band, something stretchy, right? When you take that Silly Putty or you take that rubber band and you stretch them, you notice that the Silly Putty or the rubber band gets narrower or thinner, right? So if you think about that, right, a vertical stretch will cause the graph to appear narrower. And so we got to really kind of reconcile what we see with the terminology. Okay, so we call it a vertical stretch. It looks narrower to us. Okay, this is my attempt at giving you guys an analogy to kind of make that word make sense to you. Okay, we're stretching it, making it look thinner, look narrower. Okay. Something else I want to point out to you guys here, it deals with the slope of these things, and this is something special for this particular function. Other functions that we do won't be made up of the same like pieces. If you think about like the way this looks, an absolute value graph really is just two lines that are connected. Okay, and lines have slope. But other graphs that are curves, they won't have slope, but they still have rate of change. We've talked about that, but it won't be like a nice, neat little thing that happens with that. So if we think about that slope of our original line, right? If I start here, my vertex, I go up 1, and then I go over 1. The slope would be 1 over 1, which is just equal to 1. Well, guess where there's a 1? Right there in front of the bars. Okay. If I look at the slope of my new graph, so from here to kind of a corresponding point, I'd have to rise 3 and then run 1. All right, so the slope would be 3 over 1, which, well, where's that? It's right there. Okay, so for an absolute value graph, you can kind of think of this number here in the front as describing how the slope is going to look for that graph. And why I'm kind of getting after this for you guys is because some of the questions you guys are trying to answer tonight, you're going to be using a graphing tool to try to draw the graph on the homework. And so they'll have you, just like on the stuff you guys did Friday, you'll be like, you can drag stuff around, okay? And so you'll drag it to where the vertex is. So like for this, the vertex will just be at 0, 0 because there's no shifting happening. But then you have to drag another point. So you drag that and you plop that point down, and you have to grab another point, just like you guys did on Friday, and then try to shift the line around to change the angle. Well, how do I know what angle to put it at? You look at the slope. So if I had a slope of 3, I would grab that other point, I would move it over 1 and up 3 so that it's at the right movement. If I had a slope of like -2, then I would move it down 2 and then over 1. And then that point would be plotted, and then it would draw the rest of the graph for you. All you have to do is plot 2 points, and it does it just by dragging stuff around. So you throw the vertex down, and then you drag another point to where it should be based off of the slope, okay? And then it'll draw the rest of the graph for you. Okay? And that's going to be something that you guys are going to need to play around with and try to figure out as you're doing this stuff. And some of this stuff we're doing right now with that online stuff is you need to play around. You need to figure out what you don't understand how to do because of the software versus what you don't know how to do because of the math. So that's something you guys got to kind of discern, let me know where you need help. I don't understand how to do it on the program versus I don't understand the math of it, or I don't understand both. Help me, right? So again, just kind of think of that as the slope though, and it can help you plot a point. Yeah. Oops, not what I meant to. Okay. So that language we're going to use here is the graph is stretched. So it's a vertical stretch vertically. And then here's the special phrase you need to have in your sentence: by a factor of, and then 3. Okay. So you need a verb, you need a direction, and you need a size, just like on the other ones. But also you need to have this phrase, by a factor of. What this tells us is that there's multiplication happening here, not addition. That's how we verbally differentiate between a shift and a stretch, is by that saying by a factor of, because factors are things that multiply together. So we're talking about that this is a multiplication math here. Okay. There are horizontal stretches. We're not going to talk about those today, but just why you need to talk about that, like versus one versus the other. There's a way to stretch a graph horizontally. Okay. So because that was bigger than 1, it made it stretch. 3 is bigger than 1. Let's look at the 1/3. So when you want to type 1/3 in there, you can just hit 1 divided by 3, and it'll write it as a fraction for you. Camilla, how would you describe our red graph in comparison to the black one? Camilla, you there? Okay, Tion, what about you? How would you describe the red graph in comparison to the black one?
It's
wider, right? It looks wider, right? That other one looked narrower, this one looks wider, right? So the 1/3 makes it look wider. What this is called is a vertical compression, okay, or a vertical shrink. We use the word compression. Okay, so again, go back to our silly putty idea, right? We have that little ball of silly putty and we press it down, okay? And that means it's going to expand out to the sides. So we compress the points, they look wider, okay? So this is a vertical compression. So notice how I'm changing the order of the sentence, but that's okay. I'm still writing the same words. I'm just writing them in a different order. So vertically compressed, and again by a factor of. Okay, so verb, direction, size. Then you need this phrase for the stretches and the compressions. I want you guys to note what we were just talking about, like that this appears narrower or appears thinner. And this one appeared wider. Okay, that's going to kind of go against what you might think, right? You might think a compression should make things thinner. Right? You might think that a stretch should make things look bigger, and bigger sometimes, the wider ones often look bigger to us. Okay, so we got to make sure we kind of reconcile what the math terminology stretch, but it stretches that thing to make it look skinny, right? Compression, it pushes it down to make it look wide. Okay, so how do you make sure you get the appearance matching up to the vocab? The appearance, the vocab. Okay, so watch out for that. Again, the sign switch tricks a lot of people. Okay, last one. I had negative. A lot of you guys, when we talked about this, like that very first worksheet, you guys understood what a negative would do already. Right, when we talked about it on a parabola that we were looking at. So just throw a negative in front of there. And of course, that just flips it upside down. What that's called is a reflection. And it'd be a reflection over your x-axis or a vertical reflection. Okay. So a negative in front will do a vertical reflection or a reflection over the x-axis. Notice how on all of the multiplication ones, the stretching, the compressing, the reflecting, notice how the vertex never changed. It didn't move anywhere. It just was changing the angles or flipping upside down, but the vertex never moved. So the graph, different color, is reflected over the x-axis. Or you could say the graph is reflected vertically. So notice on this one that there is no number, right? We had the 3s and 3 and 3 and 3 and 3 and then a 1/3. Right? There's no number here. You can't reflect something 3 times or something like that. It doesn't work like that. It's either reflected or it's not. Right? It's either positive or negative. Okay, so there's less information here, right? It's just verb and then direction, right? Verb and direction, but no size component to this. Okay. We're going to go back over this, but in a more general way. So we're going to take all the 3s and stuff out of this. Is there something you want me to make sure I kind of highlight as we talk about it again? All right, let's flip to the other side. I do need you guys to change something right now. Not happy with the letters that are here. So on this, the third and the fourth one, those should be K's. And then the fifth and sixth one should be A's. I'm actually going to change this whole thing here. I don't like that one bit. I should say 0 is less than the absolute value of A, which is less than 1. So what we're looking at here are going to be general ideas, okay? Taking all the letters out, or sorry, taking all the numbers out. We're going to be looking at a general form of an equation. So later on, you're going to become very familiar with this, which is the vertex form or the transformation form of a quadratic, something that would graph as a parabola. Or here's what we're talking about right now, which is the absolute value function. So think back what you guys were doing Friday, right? It started you off like, what happened? Or how do I, what do I do to get this number? Or when this number changes, like what's it do to the graph, right? When this number changes, what's it do to the graph? What happens when I change this number? What did it do to the graph? And by the end of it, you were like, they're asking you to like try to do all of it. Okay. Each of these A, H, and K can be changed into a number, and each of those numbers would then have a different effect, right? Based on how big it is or its sign, right? Kenzie, you're talking about like where, the placement of the numbers, right? If I want to shift something left or right, I need to mess around with this number. If I want to shift something up or down, I need to mess around with this number. If I want to stretch or compress something, I need to mess around with it, or reflect. I need to mess around with this number, okay? So the placement of the number matters. And again, we're going to talk about the horizontal stuff later. That was when there was a number multiplying right here inside of the parentheses, but right in front of the x. We're not going to get to that just yet. Okay, so there would be even a fourth one. Okay, and what did we see just on the other side, right? When it said plus something, what was our movement? When it was plus something inside of the function, what was our movement like? How did the graph move when we had plus some number inside of the function?
Move to the right. No. Left.
Yeah. So this would be a left shift or left movement, right? So the graph will shift, and I'm going to change colors on this just to highlight that again. Left, and then I'll just say H units. Okay. Yeah, whatever H is, if it's 5, if it's 12, if it's 30,000, right? So again, left on that. So in that same way, oops. When it says minus, that was our right shift. I'll change colors to kind of highlight that. And I mentioned this earlier. You guys might want to write it down now. I like to always talk to my students about that H is a liar. This is, again, not something that's going to be like a one and done. We're going to very, very often see that this number inside of something is going to do the opposite of what we think it would. Okay? When we're working with stuff, when you're working with values inside of the function, like that's inside of the square, this is inside of the absolute value, it's going to do the opposite of what we think it will. And it happens a lot. And so just kind of getting this idea down that we can't trust that guy that's inside the parentheses kind of help us learn that stuff later on faster. Okay. What about if we put a number on the outside, positive number on the outside, what happened to our function, our graph? Shift up, right, Tian? Okay. And that one we can trust, right? So I'm not gonna change the color on that one since we can trust it. But shift up K units. Okay. And then, oops. And then, switch that to a minus sign, and it does what we think it would. Okay, so where do our left and right shifts happen? Where do our up and down shifts happen? Okay. And then we went to stretching and compressing. Okay. So if the number in front of the function is bigger than 1, so if it's 1.1, if it's 30, okay, it doesn't matter how big it is, okay, it'll stretch the graph. It'll stretch it more versus, if it's a bigger number, but it's still a stretch, okay? So as long as it's bigger than 1, absolute value is bigger than 1, it'll stretch the graph, make it look narrower. Okay. So stretch vertically. And by a factor of, so I'm going to put that in a different color here, just because I want to highlight that we need to use that phrase. Then we just say by a factor of A, whatever A is. Again, we won't say A units. So the graph will stretch vertically by a factor of A. If A happens to be between 1 and 0, again, not negative, but some number between 1 and 0, so like a small decimal, a small fraction, okay? I know we're about to out of time here. We're almost done. So a decimal fraction, not negative, that's usually a pretty big misconception. Negatives don't make you compress, okay? Decimals and fractions do. That's going to be, the graph will compress vertically. Again, by a factor of A. And the last one with the negative is, is a reflection. So that's where the negative pops in. That's what the negative does, it reflects. And so again, I need you guys to try those problems that are on the other sign there, okay? I need you to go in and see if it's the math that's bugging you, if you're not sure what a certain phrase is meaning. Remember, you have tools like glossary and stuff like that. You can look that up. If you don't know how to move something, you don't know what to type, like if it's more of a software issue, I need you to write that down. Okay, on number 4, I don't know how to type my answer. I know what to do, or I don't know how to drag the points right. I know what I want to do, but I can't make it happen. I need those different types of questions that you're coming at me with. You try number 1, it's not working, so you go to number 2 and you figure out number 2 out, and then you try number 3 and you don't know sure about 3. Okay, so go through all 9 questions and see which ones you're able to do, which ones are math issues, which ones are software issues. Okay, don't let me down like a lot of you did last time. Not even trying them does not help if you don't try, because I can't help you figure out what to do. Okay. So please go get those tried out. Okay, I'll come back tomorrow with questions on the software, on the math. Okay?